Welcome everyone to section 1.1 of Algebra 2. We're going to be going over graphing in three forms with linear functions. So you guys are going to be able to graph linear functions in three forms like I just said. Quick little warm up. So find the x-intercept and the y-intercept of the following equations. We talked last class in 1.0 how to do that. We said for each intercept, make the other variable 0. So for the x-intercept, I'll make y 0. Now you might have noticed by now, after doing some problems on the homework and whatnot too, that what happens every single time is when a number multiplies with zeros, you get 0, and you just end up having like the negative 2x equals 8. So you divide by negative 2 on each side, and x equals negative 4. So the x-intercept is negative 4, comma 0. And I should say x-intercept specifically. Then for the y-intercept, same thing will happen. As far as I'm concerned, honestly, I could just write 4y equals 8 and solve that, because when I do negative 2 times 0 instead of x, that's going to go to 0 anyway. So I really don't even need that if I don't want. So I could just write 4y equals 8. Now if you need to write it or you want to write it, feel free to continue doing that. So I divide by 4, and y equals 2. So now I have my y-intercept is 0, comma 2. So I found the x and y-intercepts. We'll do the same thing on the next problem. So for the next problem, 0 equals 1/3 x minus 6. Add the 6 to both sides to get 6 equals 1/3 x. Multiply both sides by 3, or 3 over 1. So you can write it on each side in its own separate parentheses. Or you can write it as one big parenthesis. And say, hey, we're multiplying the whole equation by 3. Either way works the same. You end up having 3 times 6 is 18 as I run out of room there. Equals 1/3 times 3 is just 1, so you're left with 1x, aka x, which gives you an x-intercept of 18, comma 0. Now for the y-intercept, y equals, once again, 1/3 times 0. When you replace that, it's just going to be 0, so y just equals negative 6. So the y-intercept is 0, comma negative 6. Now the three ways a linear function can be written, those are going to be slope-intercept form. They're on the front of your packet in case you need them. Actually, there's not a dash there. I don't know why I'm putting that. Slope-intercept form. Standard form. And point slope form. That one has a dash. So some characteristics of each of these. This first one down here is the slope-intercept form I just talked about. And I'm going to shorten intercept down to int. M is the slope, and B is the y-intercept. Some notes on standard form, which is ax plus by equals c. So a and b are not 0. A has to be positive, not necessarily B and C though. And then A, B, and C, it's my and symbol, are integers. So aka not decimals or fractions. And then the third form, point slope form, M is the slope again. And then x comma y, or x1, y1 I should say, is a point on the line. It's important to note that in the equation for point slope form, it's y minus y1 and x minus x1, meaning how it appears in your equation is the opposite of how actually the point is. So you might need to flip the sign when working with those. So let's work on changing form from one to another. So this first example, we're going to convert from slope-intercept to standard. So it's in y equals mx plus b, and we need to get to ax plus by equals c. So we have 3 steps we're going to follow. The first step is to get x and y on the same side. So let's do that by subtracting 5x from each side. So you have negative 5x plus y equals negative 6. All right, step 1's done. They are on the same side. Step 2, the coefficient of x, aka a for the ax, must be positive. So we need to make that positive. So I'm going to multiply by a negative 1. Once again, on both sides of the equation, or you can just say I'm doing it to the whole equation. So that'll change the sign of everything. 5x minus y equals 6. It's okay that the y is not positive. And then last but not least, a, b, and c must be integers, aka not decimals or fractions. Currently they are not, so we don't have to worry about it. Now if they were, we actually would have gone ahead and dealt with that the same time we dealt with the sign change. I'll talk about those examples in a bit. Example 2, we're going to convert from standard form to slope-intercept form. So the reverse direction of what we just went. So you solve for y and simplify. So we start moving everything away from y. So start with the 2x. I'm going to subtract that and have 7y equals negative 2x plus 28. We always want to write the something x before the number at the end. Then divide everything by whatever might be with y. Y equals negative 2 over 7 x plus 4. Last but not least, we're going to go starting in point slope form, to slope intercept. We don't really convert to point slope. That's kind of a pain actually to convert to it. So for point slope, the first step is to distribute. So we'll distribute this 2. So you have y minus 3 equals 2x minus 24. Then solve for y. So you add or subtract whatever was with the y. So we add 3 to both sides to get y equals 2x minus 21. On to the next page. Let's talk about horizontal and vertical lines. So y equals 1. That's going to be a horizontal line. Think of saying, hey, where is y1? Y is 1 there. It's 1 there. It's 1 there. The y value is 1 everywhere. So it's all the way across. So whenever there's y equals a number, it's going to be horizontal. I'm just going to abbreviate that HOR. And a good thing to remember is that the slope is 0. The way I remember it is that out of this horizontal line, I can make it into a z. Example 5, x equals negative 2. So that's going to be anywhere where x is negative 2. So it's negative 2 here. It's also here, 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 and all the way vertically. So when you have x equals some number, it's going to be vertical, which I'm going to short to VERT. And this slope is actually undefined because you have some number being divided by 0 for the rise and run. So I can make a U out of the line for undefined to remember that. So Z for 0 and U for undefined. Graphing in each form. So we'll start by plotting the y-intercept. So let me write that down as the first step. Plot the y-intercept, aka B. Oftentimes I'll say begin with B. And at the same time that we do that, we also want to identify M, which is the slope. So let's go ahead and do that. M is negative 2/3 and B is 5. So we're going to begin with B. So the plus 5 tells us it's going up or right. It's going up because it's a y-intercept. Then, starting at B, we use the slope to plot additional points. So you do that by counting the rise and the run. So my slope is negative 2/3, aka rise over run. So I'm going to rise, or in this case fall, because it's negative 2. But I won't stop there because I guess I got to run 3, and it's positive to the right. And I could just keep doing that as long as I wanted, or you could even go in the other direction and go up 2 and left 3. You only really need to make a total of 2 lines. I encourage, though, making 3, or a total of 2 points. I encourage making 3 just to make sure that, we're really going where we want to go. We don't make a mistake. So then the third step, I actually already did it, was draw the straight line with arrows. And that's going to be my width, W/arrows. Just telling us it goes on forever. All right, standard form. So our steps for standard form are going to be, I should have numbered those instead of doing that. So I'll do 1, 2, 3. So we'll do the same thing here. 1 is going to be finding the x-intercept, which once again, you do by making y equal 0. Or by putting 0 in for y, if that would be better. So I can go ahead and work on that. X minus 3 times 0 equals 6. So 3 times 0 is 0. So x equals 6. So the x-intercept is 6, 0. Step 2, find the y-intercept. And if we recall, same thing, you do it by making 0, or making x 0. Or putting 0 in for x if you'd rather say it that way. So let's do that. 0 minus 3 times y equals 6. So we really just needed to divide by the negative 3, not the y. I like that where it's at. And y equals negative 2. So it's 0, negative 2. So we found both intercepts. Now you're going to plot the intercepts. So plot x, 0, your x-intercept, and your 0, y, your y-intercept. So as I go to plot those, my x, 0 is 6, 0, so 6 to the right. And my 0, y is negative 0, negative 2, so just 2 down. That was a really bad line even for me. It still was. Okay, that was probably about as good as I'll get. Now we're going to do point slope form. So point slope form, we're going to identify and plot your point you're given, x1, comma, y1. So here, remember, x1 is what's with the x, and y1 is what's with the y. And I noted earlier that point slope form is y minus y1 and x minus x1. So in order to get plus 3 in the equation, y plus 3 equals 4, parentheses, x plus 2, that originally had to be a minus there because you subtracted a negative to get that. And same thing with this, it's the opposite sign. So the point is really -2, comma, -3. And so we identified it, and now we will plot it. So 2 to the right, and 3 down. Next step, use this point, choose the point, and slope to plot more points. So the slope is whatever's outside the parenthesis to be distributed in. So 4, aka 4 over 1. So I will go up 4 to the right 1, or down 4, left 1. Now we're going to connect it with a straight line, just like we did on the last few. With arrows, like I already did. And I actually accidentally left that off here, so I'm going to write that in now. Step 4 for standard form is connect with the straight line with arrows. All right. Now we're going to go on to the next page, which is the last page for the section. So they say on your own examples. So if you're watching this video, please pause, work on these examples, and then continue the video to check if they're correct. So go ahead and pause that now. All right, welcome back after you worked on those. If you didn't pause it, that's going to sound really awkward because I just said welcome back after some silence. So number 1, write an equation of each line in standard form with integer coefficients. 3/4 x equals y plus 8. So standard form, I need to move the x and the y to the same side. So move the y over by subtracting it. 3/4 x minus y equals 8. Now I need to get rid of the fraction. So I'm going to multiply the entire equation by 4. Because that gives me 3x instead of 3/4 x. Now it also makes it negative 4y instead of y and 32 instead of 8. And that's okay. So that will be our answer. On letter B, same idea, I'll move the x over to start. So I'll get 0.33x plus y equals -6. Now, I don't want any decimals, so I'm going to multiply by 100 because there's 2 decimals there. So I'm going to do 2 zeros to get that out, because that moves the decimal over 2 times. That'll give me 33x plus 100y equals -600. So it made everything bigger, but that's okay because it got rid of decimals. All right, next we have example 2, converting to slope-intercept form. So this one's solving for y again. So I'll start by adding 19x to each side to get 4y equals 19x plus 7. Then I'm going to divide everything by 4 and get y equals 19 over 4, x plus 7 over 4. And even though 4 doesn't go into 19 or 7 at all, we still want to separate those fractions so that way we emphasize the point slope form so we can see the mx and what the separate b is. Example B, in number 2, we first distribute 2/3. So you get y minus 6 is equal to 2/3 x, and then 2/3 of negative 18 is negative 12. Then we add 6 each side to get y equals 2/3 x minus 6. On examples 3, A and B, we find the slope and y-intercept of the graph, the following equations. Slope and y-intercept and graph, the following equations. So A, 2x plus 5y equals 20. We need to get it in the y-intercept form or slope-intercept form, So we'll have to do the same thing we did on number 2. I'm subtracting x to start, removing x to start. 5y equals negative 2x plus 20. And we're going to divide everything by 5. It doesn't go into negative 2x, but it does go into 20. So now we have the slope is negative 2 over 5, and the y-intercept is 4. So for that, we go up 4. I'm going to zoom in so I can see it better to start, because we begin with the b, and the slope of negative 2 over 5 means it's going to go downhill. So it goes down 2, and to the right 5, or up 2 and left 5. Connect with the straight line and arrows, and it's graphed. Example B, there's no y, so we should have a hint from earlier that it's going to be a vertical line of some sort. So let's solve for x to figure out what vertical line that will be. So we divide both sides by negative 4 to get x equals negative 3. So if we remember, the slope of these lines is undefined, and there's no y-intercept. If you don't remember, graphing it after you say, okay, where is x equal to negative 3, and everywhere on that, then you can make the u out of it. Let me choose orange to make that a little pop a little more. To say, hey, that's an undefined slope. All right, last but not least, we have example 4 with A, B, and C parts. So graph the following equations and identify the form. Okay, so for A is point slope form. You can tell because we have y plus or minus a number, x plus or minus a number, and a number outside the parentheses only with the x and another number. So here we can know the slope is 3 over 4 because it's outside the parenthesis, and a point is 4 comma negative 2 because you do the opposite of what's with the x and the opposite of what's with the y. So let's go ahead and start by graphing 4 comma negative 2, and then use the slope of 3 over 4. And that's our line. Letter B is in slope-intercept form, typically our favorite of the 3. We know the slope is 1/3, and the b, and the y-intercept is negative 4. So we begin with the b of going down 4, and we go up 1 and to the right 3, or down 1 and left 3, or both. Connect them, and on to letter C, which is in standard form, which you might have guessed. Standard form, remember, it's a good idea to do x and y intercepts. The x-intercept is going to be plugging 0 in for y, and the y-intercept again will be plugging 0 in for x. So the x-intercept is going to be negative 3, 0, and the y-intercept is positive 5, 0. So we graph those, connect those points, and we are done with this lesson.